We started with the MEMP development quite a number of years ago, and the reason, apart from the business approach, was of course that we had a number of very knowledgeable people, enthusiastic people. I won't mention all of them, but especially I would like to mention Engineer Sozzi, who was then the responsible for our marine department. The second point was, of course, that the development was made in conjunction with the Italian Marine for the new submarine, which they had planned to develop at that time. And this, in combination also with our deep involvement in the propulsion technology for all kind of ship surface and not surface ship, made this project a very interesting project for us at that time.
Modern naval vessels have to meet very low signature levels in the field of infrared, radar cross-section and noise. Effort to reduce signature levels has very high priority in the Italian Navy, that is dedicating to the problem many energies. In addition, Italian Navy is aware that the trend to adopt in the next future all-electric propulsion system for naval vessels will make stringent the need to get high efficiency, high reliability, and low noise signature electric motors. For the mentioned reason, the Italian Navy funded an R&D program based on ABB electric motor design. The prototype test results were consistent with the expectations both for airborne and structure-borne noise. The Italian Navy therefore decided to install the new motors on board its new multipurpose vessel. In service date is scheduled for 2002.
The aim of this project was to produce an integrated modular electric drives for submarine propulsion to deliver 4.3 megawatt at a speed varying between 0 and 150 rounds per minute. The purpose of the project was to create an application that would improve different aspects, such as limited volume and weight, higher reliability, higher efficiency, lower noise, as requested by Italian Navy. First and foremost, an equipment layout that, with the same external volume, could maximize the rotor diameter to maximize the power with all other conditions unchanged. The use of permanent magnet technology, which has been developed over the years and is already applied in the smaller sized motor, contributed to limiting the volume. The choice of a modular structure, dividing up motor operation into 4 submotors, each of which is powered by several modules in parallel, with a total of 192 single-phase inverter, which is equivalent to a group of 16 elementary machines, permitting the achievement of high efficiency with beneficial effects on noise level and on the availability of the power motor system too. Another aspect worth underlining is the fact that there is double metal housing, one inside the other, to permit, when necessary, more rapid access and smelting of the modular parts. This solution is of an integrated type in that the electronics are housed within the metal housing of the motor itself.
Main problem of this type of motor is structural and aerial noise. In order to control this type of problem, we designed the rotor and stator units in order to avoid the resonance condition, at least for the first harmonic, between the exciting electromagnetic field forces and the natural frequency of stator and rotor. Due to the fact that it is quite impossible to avoid resonance condition for higher order harmonics, we decided to put between the stator ring carrying the magnetic unit and the stator case a rubber support in order to decrease the vibration transmitted to the external case.
MEMP is a modular structure drive controlled by a motor control computer linked to 32 power electronic modules carrying out the following functions. It establishes the number of operational submotor and modules according to the load to achieve maximum efficiency, minimum noise at each speed. It permits the operator to keep watch on the references, measurement and any alarms. It permits gradual dosing of the torque delivered at all speed in both rotation direction to prevent propeller cavitation. The following requirements were considered essential in the project specification for the control in order to ensure high reliability for the MEMP drive. High diagnostic capacity, redundant architecture to minimize the risk of serious deterioration in performance in case of malfunction, detailed mapping of the temperature within the equipment, exact measurement of current and voltages in most significant points in the control system, a serial connection with the control system and a well-designed graphic interface greatly simplifies MEMP operation.
The transposition of the electromagnetic, electronic and mechanical basic design into drawings and manufacturing technologies was one of the most demanding steps of the project. The mechanical layout of the machine has been largely influenced by the request of the customer specification. The solution adopted led to a machine structure that is unusual if compared with the standard electrical machines. Teams formed by experienced specialists of different technologies worked together for a long time in order to conceive the right technical choices and the most reliable solution. The overcoming of the technical problems required the engagement of these teams along several main years. The result was the development of a dramatic amount of new and never adopted working methods, tools, and technologies. A separate project was the realization of the test equipment. The design of the test facilities has to take into account the system to apply the load to the machine axis and the method to measure the efficiency with the required precision. The vibration insulation between the machine, the basement, and the load equipment to allow the measurement of the extremely low structural vibration. The control and the protection system. The required check under rotation with the machine sloped with respect to the horizontal plane, simulating the healing condition on board. The program of characterization and homologation test has been completed with full compliance to the design basis. More than 600 hours of rotation under different load and structural conditions were carried out under the witnessing of the customer inspectors with their total satisfaction.
We make a lot of tests on this motor at all the running speed, and for what concern structural and aerial noise, this was inside the specification for all the working conditions. For the future application, we can work on this rubber element in order to increase the performance of this type of motor, mainly at higher frequencies.
Apart from being a successful prototype, the multi-electronic permanent magnet motor is now a fully operative industrial reality. Exceptional quality of operation, as for structural and airborne noise, high power density by weight and volume, high efficiency also at reduced power, fully automatic auto-adaptive control, all make this drive excellent. The uniqueness of the drive, anyway, as seen by me, is due to its modularity, coupled with a distributed intelligence embedded in each power module. Actually, the drive is to be seen as an ensemble of 16 independent motors, whereby a supervising intelligence allows for automatic reconfiguration in case of fault, so letting the drive to operate without interruptions. This has today, and as far as known to me, has never been achieved elsewhere in the world. What's to be done now? I'm confident that with minor changes, mostly of software nature, one or more submotors at a time could be operated as in a generator mode to feed power to ship users. This operation would be extremely useful on board naval ship of submarines heating at reduced or low speed. I don't think appropriate in a way to anticipate in deep here now about this idea.
This has been a project which has lasted a little bit longer than what was planned, but I think this is not an excuse. This is the real reason why we had some delay in the project. The cooperation which we have had during the complete phase of the project has been very important, and I would take the opportunity to thank all the participants, of course our own people, but especially then the external one, Politecnico di Milano, Magnet Motors, ABB Ricerca, and even more so the cooperation and the support we have had from the Italian Marine organization. This has been very decisive, and especially also I'm very pleased to announce that we have received an order from the Italian Marine for not a submarine, but for two somewhat smaller motors and the MEMP motor for a surface vessel, which will be an important further step in the development of this new technology.